So let's look at how we can graph some equations using the intercepts. Now notice I have written 3x minus 4y equals 24. Now I wrote that in a specific form. That specific form is what we call standard form, or the standard form of a line. And that represents where I would have some ax plus a by equals a c, where in this particular case, a would equal a 3, b would equal a -4, and c would equal a 24. So when we're able to recognize a line that's written in standard form, one of the things we can do is look at their intercepts to see where that line crosses the x-axis, and if so doing that, we can find out where the graph will be at. So let's look again at 3x minus 4y equals 24, and I want to ask, what is its x-axis? Where does it cross the x-intercept at? Is a better way to do that. So what do you remember about lines or about points on an x-axis? Which value is 0? That's right, the y value is 0, and that means it crosses the x-axis. So what we'll do then is we're going to substitute 0 in for the y, and solve that for my x. 3x minus 4 times 0 goes away. 24, x equals 8. So I know that the point 8 and 0, because this represents the point 8 on the x-axis, 0 on the y-axis, those were the 2 points I put in. Y was 0, and we discovered x is 8. So we have an x-intercept of 8, and that point, or the coordinate point, is at the point 8 and 0. So I know that point is on this line. Now let's look at the same equation. We know what its x-intercept is, so obviously we want to find out. That's right, it's y-intercept. So how do we do that? We set the x equal to 0. And then solve for y. Divide both sides by a -4, y equals a -6. So I have a y-intercept of -6, and how would I write that as a coordinate point? Well, I know my x is 0, my y value would be -6. So this coordinate point, because the x is 0, tells me my y-intercept is -6. So let's look at this equation and see if we can graph it based on the ideas that we're learning about intercepts. So let's look for its x-intercept and its y-intercept. How do we find its x-intercept? Do we set x or y equal to 0? I think we set y equal to 0. So let's do that. So it's 3x plus 2 times 0 equals 6. 3x equals 6. X equals 2. So I have an x-intercept of 2, and the coordinate point would be the point 2 and 0. Now let's solve the same one, but this time set x equal to 0. So I have 3x plus 2y equals 6. I want to find its y-intercept. When I do that, I set x equal to 0, because I make x go away. I want to find the y. Whoops, yep. And then y equals a 3. And then I have a location point of the point 0 and 3. So those are 2 points that I have on the line. That's where it crosses the intercepts. However, remember that we typically want to try to find 3 points just to make sure as a check that we didn't get one of these points wrong. So what we can do then is just do a test point. So for example, let's find out what happens if x is 1. And that's just my test point that I'm going to choose. So here's my equation. I'm going to put in a value of 1 for x. 3/2, or 1.5. So I know that I have another point on this graph that's at the point 1 and 3/2. So my goal now is let's go ahead and graph these. So I have the x-intercept over 2 up 0. I have the y-intercept over 0 up 3. And my test point, if I didn't make a mistake anywhere, that test point should line up on this line fairly obviously. So over 1 up 3.5. And that does look like that this line, if I were to draw a line through the intercepts, also catches my test point. If I had 3 points that were not on the line, then I knew I would have made a mistake somewhere and I would have graphed the wrong line. So it's a good idea to do a test point if you can. So that's kind of how we graph lines by using intercepts. All right, let's give this another shot. Are you ready? 2x minus y equals 4. Let's graph that by using intercepts. Notice, first of all, I have it in standard form. Sum ax plus by equals c is the form. So let's find the x-intercept. We do that by setting y equal to 0. Solve for x. So I have an x-intercept of 2. Let's look for its y-intercept. When we do that, we set the x equal to 0 and solve for y. And now we have a y-intercept. Then lastly, I mentioned it's good to find a test point just to see if one of these, if we made a mistake somewhere. And I usually like choosing 1 as my x value because 1s are nice, smaller numbers where it's less likely for me to make a mistake. So 2 times 1 is a 2, minus a y equals a 4. Subtract 2 from both sides. So I know I have a point 1 and negative 2 on this graph, assuming I didn't make a mistake anywhere, which is always possible. We make mistakes all the time when we do these things. That's what learning's about. So let's go ahead, draw our axis or grid, put a good scale on it. And so I have a point where it crosses the x-axis at 2, crosses the y-axis at negative 4, and then I have a test point over 1 and down 2. Looks like those 3 lines or those 3 points are consistent, meaning that they're all part of the same line, which gives me confidence that that is the graph of that equation as we found by looking at their intercepts. So how are you feeling about that? Feeling all right? Kind of getting the hang of it? Cool. We remembered from earlier, not all lines cross both axes. Sometimes we have lines that cross to the origin. And we know that there's an infinite amount of lines that cross through the origin, depending on what its direction is. So we have a line written in standard form, but the right side equals 0. And that tells me then that x plus y equals 0, and therefore I have a line that goes to the origin. So what do we do? Because we need to have 2 points to determine a line and a third point to make sure that we didn't make a mistake. So what do? Well, we know that we already have 1 point. It's the point 0, 0. From there, let's just do our test points. So let's say that y equals 1. Solve that for x. So I have a test point of negative 2 and 1. Now let's find another test point because now I have 2 points total. The origin and 1 test point. Probably should find a third test point or a second test point. And let's do x plus y. Let's set y equal to negative 1 to get a negative value in there. See what happens. X minus 2 equals 0. X equals 2. And so I also have the point 2 and 1. Sorry, 2 and negative 1. Did I skip ahead too quickly there? X minus 2, x equals 2. So let's go ahead and graph that. Have our grid. Let's put a good scale on it. We remembered that it goes to the origin. Many lines go through the origin. The line that we're looking for also goes to the point negative 2 and 1, backwards 2 and up 1, and also has another test point that's over 2 and down 1. And there it looks like all three of those points are on the same line. So it gives me confidence I did not make a mistake here. Don't you like it when you do a problem without making a mistake? Only wish we could do that every single time. All right, so that's what we can do, is understand that sometimes our graphs go through the origin. When that's the case, we need to find 2 test points from there to help us give us the accuracy on what that graph would look like.